Hello everyone, welcome back to the third session on Kubernetes cluster architecture. Let me share the screen. We have done two sessions now. This is going to be the last actually on the Kubernetes architecture. And here let's do a walkthrough on the cluster components interactions. So how the workflow happens within the cluster, right? This is going to be very important. So let's do slowly, right? And okay. Components workflow. The very first thing is kubectl, right? So we know kubectl is one of the client tools where we can use to interact with the cluster, right? So, and I may remember while doing the cluster configuration, we install this one in each node, right? And you can see on here, .kube and minikube. So, I mean, you may remember this folder, right? And minikube is, if you are running with minikube, so .kube, which has the information, the config file, where it tells the kubectl which cluster to connect. That's right. The context of the cluster is given to the kubectl using .kube. I think if we just recall this one, I think you may remember in our practical, right? So this is remember this what once the master node is initiated, the output of that command kubeadmin init command with the podnetter, it gives you this path, see .kube and then the config file. And if I just play this one for a while, and you can see here, if I now we are visiting to that directory, right? So this is just to recall, and the config file is there, right? And within the config file, if you check that, you can see the contents. It tells where is the cluster and the port information, right? So here is this is the video I'm just playing, and this is about the cluster key, right? Where is required again for the authentication purpose, and this is the cluster name and the default port where the traffic is flowing into the cluster. So that is the .kube and the config file, right? So it is it tells the kubectl where to connect, right? So let's continue, and having those configurations, let's say that now kubectl knows, right, where the within the, I mean the authentication information and where to connect within using the config file. So the profile information is done for him. Then what happens? It can interact with the API server, which is the gateway for the Kubernetes cluster, right? So you may run the command. I mean, you have seen in the previous practicals, kubectl apply, kubectl create, whatever deployment, whatever resource creation, you are just running a command with this client tool. And whatever the command, the first interface to get into the cluster, the first interface is kube API server, right? So then, I mean, depending on the component, because in between, even though I haven't mentioned here, there can be several components like the gateway authentication, English gateway authentication, even the service mesh information may be there, right? And again, if service mesh is not there, service discovery server, so those things are coming here, the load balancers and all, right? But whatever the interaction, the first thing, kubectl will hit the API server, right? So then API server has these information, because it needs to have definitely etcd, because what is happening in the cluster as of now is available in the etcd, and it needs the information from there, as well as API server needs to update the etcd database, the key value pair database as of now, what is happening in the cluster, right? And due to let's say a new workload take place, so therefore this particular node, the worker node, is going to bear this new load, so that the new information, the resource availability will reduce because of the new workload. So those information has to be passed to the etcd once the deployment is done. But as of now, this is the workload. So those information will be fetched from the etcd by the API server, likewise, right? And again, API server interacting all of these components. Kube controller, right? Again, about the controlling information, right? Whether the node is up, node is dead, or what is active, likewise. And it interacts with cloud controller manager as well if it is there in place, right? Okay, so having taken that information because of this request, right, to be deployed a new workload to the cluster, then the very first thing is the authentication. The relevant request should be an authorized request to the API server. So validate an authorized request, validated an authorized request by API server. So outcome is a validated, compiled, authorized request from the API server. Right. So to where it goes, this authorized request, it goes to the scheduler, right? Scheduler. So that is what's going to happen, right? So this is the very first initial workflow, right? It's going to happen. The request is taken now by API server and it validates, authorized, and is compiled by looking at the other information from etcd and kube controller as well, right? Then it's passed to the scheduler. So why is passed to the scheduler? Because the next requirement is to what? In order to deploy this, we need to have the pod up and running, and the containers need to be pulled and run, right? And be images need to be pulled and executed. Then the containers will up and running. So scheduler will take care of that in combination with what? Kubelet. That's what's going to happen. So now the master server via the scheduler is going to interact with the worker node, right? Right? And it will take the worker node because this kube scheduler has its own logic. It has its own logic on how to select the best worker node for this workflow, right? Like example, it has techniques like filtering, right? Filtering is one of the techniques, and it has a scoring technique, right? So let's get into those in more detail. So it has its own logic to find out which is the best node to deploy this particular workflow. Another thing to remember is the API server and kubelet. All these interactions are REST API calls, REST API calls, because these component itself and other containers. API server is another container. Kube scheduler is another container, because Kubernetes cluster itself a set of containers, right? I think in the upcoming practicals, we will deep dive into the container, and we will see each of containers, how those things are configured even, and we get into the container, we do a lot of practicals, right? So for the time being, these all are containers, right? So what's going to happen? Scheduler is going to tell kubelet, which is a process running on the worker node, see there's a requirement, right? There is a workload, there's a manifest file or whatever workload deployment is required. I need to run this deployment in this worker node. So then kubelet, what is going to do? All right, so give me the information. So he's going to get interact with the container runtime, because now deployment means it needs to initiate the pod, and within the pod, it needs to pull the images and run. Then the containers will come up. So to do that step, it needs to interact with the container runtime, right? So what kubelet does, it talks to the container runtime, not only the container runtime, it needs the node details as well, because these containers are working, is working together with node, Docker runtime, right? It needs the VXLAN, right? So therefore, kubelet needs node network information plus the container runtime information. Then what it's going to do is going to initiate the pod as required by the manifest file or the deployment, right? So then what's going to happen, within the pod, we know the containers are going to run. It will pull the necessary images, and once the images are pulled, then it will run it. So what's going to happen, the containers are going to run. Then you are going to have the pod and the container both up and running here, right? So that part is taken care by kubelet. Depending on the request, respond to the request initiated by scheduler. All right. Right. So let's continue. Then comes, let's say we have the next node, worker node. So it has all the components, kubelet, the container runtime, and those components are there as it is. And okay, let's say this there's another deployment, or this particular deployment is going to the concept of namespace. That is normal, right? Because we know in a production environment, we don't do deployment without indicating a namespace, right? Because it's a way of categorizing resources and a way of arranging deployments within the Kubernetes cluster, right? And otherwise, it will always go to the default namespace, which is not recommended, right? And in a CI/CD pipeline, definitely the namespace will be included even in the tagging process of the Docker images, right? How do you tag the Docker artifacts or the image artifacts, right? So, right. So namespace is a very important concept, and within the namespace, now this time we are going to deploy pods. That's what's going to happen, right? So there's a namespace now, maybe maybe due to this request or maybe due to another request, right? So within the namespace, we are going to have pods, and in that we are going to have containers. So this deployment, it says to run something called my app. So what's going to happen once this deployment is done, we are going to have the application up and running my app, right? There's a name, just the application name, right? So my app is distributed across 2 pods here. If we include this one also, it is distributed across another pod, but let's say this my app is running within this namespace across these 2 pods, and within the pod we are going to have each pod we are going to have 2 containers up and down like this, right? So multi-pod application, multi-pod deployment, and multi-containers also within the pod. All right. So then let's say now this particular application, we need to expose it to outside, because once the application is deployed, we need to access it from outside, right? So that is done by the services. We know that, right? And this one, Kube, this is an internal service, right? So then comes the third component within the worker node, Kube proxy, right? I think earlier in the previous explanation, the component explanation, I mentioned about Kube proxy, right? So Kube proxy is another process which is running on in the worker node. So now it's going to come into play, because why? Because service creation is going to take place, right? So Kube proxy is an intelligent process because it knows, as per the external request to access the application, it will divert, right, to which node, because it knows the service information, and for this particular service, where are the ports? So those rules are available in Kube proxy. So depending on the request coming in to access the application, it will find out, okay, this is the service for this particular application, and this particular service is available within this namespace, and the request should be diverted to that one. So likewise, it is intelligent, Kube proxy. So it's managed the traffic within the cluster, Kube proxy, right? So this is an internal service to communicate between the pod, right? Not only that, now this is the external service actually, right? So this is an internal one where it's not exposed to outside, but this service is exposed to outside, and again Kube proxy is going to come into play. The same functionality will take place, right? And you can see here can be accessed from outside, and it is going across the nodes as well. That doesn't matter, right? A service, the pods can deployed across nodes. That's okay, right? As far as it's the same namespace. Those things we will discuss later in more detail, right? And this is the external service, right? And when we do the practicals, you will really get an understanding what is internal service and what is external service. For example, we have service categories, right? We have a node port service, we have cluster IP service, right? And we have load balancer, right? And because of this cluster IP is a kind of a service which is within the cluster, right? And node port and load balancers will allow it to access outside, right? Anyway, so ultimately the service concept will allow to expose whatever the application is running, whatever the deployment running within the cluster to be able to access from outside, right? Yes, okay. So Kube proxy, again, it will route the external request to the relevant port, and it will make the external caller to access the internal application running, right? All right. So yeah, so that is a very basic explanation. We can't say it's basic, it's a middle level explanation. It's not a total deep dive, but middle level explanation for you to get an understanding about how these cluster components are interacting each other. All right. Yeah, I hope you can, if you have any queries, you can put on comments, and contact details also here, right? You can see it here. And so that's going to be the last session on this Kubernetes cluster architecture explanation, right? So if you like the video, you can put a subscribe, and I'll meet you soon with the next video. And there will be a evaluation for this one. So I will add the evaluation for this video as well. So at the end, we are going to have some set of questions, right? So to see whether you have learned it properly. The architecture is very important in the Kubernetes deployments in a production environment. So because that will put you the base, right? On top of that, only you are putting your rest of the learnings, right? So it is very important to have the architectural understanding. Right? So I'll put the question, yes, we can try out that one as well. All right, I'll meet you soon. Okay, have a great day, right? Bye bye.